Okay, so we're going to talk about regular polygons, and we're going to hit 4 main topics on regular polygons. The definition, what they are, how to name them, how to find missing angles using the idea that they're regular polygons, and then talk about the symmetry lines of regular polygons. So regular polygons, definition, ideally you need 3 things. The first is the shape has to be convex. Remember that convex kind of means no dented. You can, no matter where you put 2 dots, you can always connect the segment inside the shape. Second, you have to have all equal sides. Okay, we can think of quite a few polygons that are convex and have all equal sides. But not only do all the sides have to be equal, you have to have all equal angles as well. So these are the 3 things you need: convex and all equal sides and all equal angles. It's not an or, it has to be all 3 of these. Now, there are 2 common regular polygons that we've already dealt with quite a bit. The first is the equilateral triangle. Because an equilateral triangle, all 3 sides are equal and all 3 angles are equal. In fact, all 3 are 60 degrees. The second is the square. All sides are equal and all angles are equal because all angles are 90 degrees. In fact, the equilateral triangle is the only triangle that is a regular polygon, and the square is the only quadrilateral that is a regular polygon. Okay? You have a rhombus, which would fit these 2 definitions, and you have a rectangle, which would fit these 2 definitions, but you need all 3 to be a regular polygon. So this is the only triangle that's a regular polygon, and this is the only quadrilateral that is a regular polygon. Okay, you may want to pause and write that down. After the triangle and quadrilateral, there are no more special names. So if I ask for the regular polygon that's a triangle, your answer would be equilateral triangle. If I ask for the regular polygon that is a quadrilateral, your answer would be square. If I ask for pentagon, hexagon, after that, you just call it regular pentagon, regular octagon, or regular 15gon. Okay, after the equilateral triangle and the square, there are no more special names. You just say regular, whatever polygon you're talking about. Once again, a regular pentagon would have to be one that is convex, have all equal sides, and all equal angles. Okay? So we've gone through the definition and we've gone through how to name them. Pretty simple. Next, I'm going to erase this as well. How to find a missing angle. Well, if you remember, okay, with a triangle, we know that all triangles add up to 180 degrees. And with an equilateral triangle, we knew that all angles had to be equal, so we could split that 180 degrees into 3 equal pieces, and we got 60 degrees apiece. So each angle of an equilateral triangle is always 60. A square could be much the same thing. The angles of a quadrilateral always add up to 360 degrees. For a square, they have to be split into 4 equal pieces, so we would divide by 4, and we would get 90 degrees apiece. So if you kind of notice a pattern, for any shape, you take the total of what the angles are going to add up to. And if you remember, you find that using this formula. N minus 2 times 180, that's the polygon sum formula. That tells you what the sum of the angles will be. So for a pentagon, I would know what that adds up to. For a hexagon, decagon, anything. And then on the bottom, you just divide by the number of angles you have. So if you have the sum of the angles divided by how many angles you have, that will give you what each angle measure is. This only works with regular polygons. It will not work with any others. So this is the formula to find each angle measure of a regular polygon. And I make a big emphasis of that because I've seen people make that mistake of extending this to polygons that are not regular. So we've gone through the definition, we've gone through how to name, and we've gone through how to find an angle measure of a missing angle in a regular polygon. You just find the sum divide by the number of angles that you have. Last, we have symmetry lines. An equilateral triangle. Remember, we've talked about how that has 3 bases versus the isosceles triangle 1. So the equilateral triangle gets 3 symmetry lines. They should all meet nice and neat in the middle. I just can't draw that well. Then if you remember with the square, that got, make my markings here. The square got the same 2 symmetry lines that the rectangle gets through the parallel sides. And then it got the 2 symmetry lines that the rhombus got through the ends for a total of 4. So the triangle gets 3 symmetry lines. The quadrilateral gets 4 for the regular. There's a pattern here. It's pretty simple. A regular pentagon will get 5. A regular hexagon will get 6, so on and so forth. So, make myself a little room. The number of symmetry lines for a regular polygon only equals the number of sides the shape has. Okay, this only works for regular polygons. When all the sides are equal and all the angles are equal and it's convex, then your number of symmetry lines is exactly equal to the number of sides. So if I ask how many symmetry lines does a regular 11agon have, well, the answer is it would have 11 symmetry lines because that's how many sides a regular 11agon has. And those are the main points of our regular polygons. Definition, convex, all equal sides, all equal angles. Your square and equilateral, the only specially named ones. After that, it's just regular, whatever the polygon name is, regular pentagon, regular hexagon. You find the missing angles by finding the sum divided by the number of angles you have, and your number of symmetry lines will always equal your number of sides.